In this video, we are going to see about metal carbonyls and also application of coordination compounds. Now, what do you mean by metal carbonyl? We know that carbonyl is the IUPAC name of the ligand carbon monoxide, and you know the symbol of carbonyl. It is denoted by CO. And metal carbonyl means the coordination compound in which the carbonyl group is linked to the metal atom through a coordinate bond. And in metal carbonyls, the metal atom will be in zero oxidation state. So let's see the examples of metal carbonyls and structures of these metal carbonyls. And we have to study 5 metal carbonyls and their structures. The first metal carbonyl is nickel, tetracarbonyl nickel, and the formula of tetracarbonyl nickel is NiCO 4 times. The IUPAC name is tetracarbonyl nickel, and I told the oxidation state of the metal is 0 in this, 0. If you calculate the oxidation state, you will get the oxidation state of nickel as 0. Nickel is oxidation state you don't know, so you denote it as X. Carbonyl group, it's a neutral compound, so 0. And it's a neutral coordination compound because there is no charge on the complex ion, which means that the oxidation state of nickel is 0 in this compound. Now, let's see the structure of tetracarbonyl nickel. Tetracarbonyl nickel, the shape is tetrahedral. So, if you are to draw the shape of tetracarbonyl nickel, nickel with 4 carbonyl group, and this is tetrahedral in shape. Now, the second metal carbonyl is pentacarbonyl iron 0. So, the second metal carbonyl that you have to learn is pentacarbonyl iron 0. Means the iron is in 0 oxidation state. And the shape of this compound is trigonal bipyramidal. And the shape when we draw is iron at the center and the trigonal bipyramidal shape. CO, 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 CO. You know that there are 2 axial bonds. These 2 are the axial bonds and 3 equatorial bonds. And you know the axial bonds makes angle of 90 degree and equatorial bonds makes an angle of 120 degree. So this is pentacarbonyl iron 0. Now the third compound metal carbonyl that you have to study is hexacarbonyl chromium 0. So the third compound metal carbonyl is hexacarbonyl chromium 0. Now the shape of this compound shape is octahedral. You know there is hexacarbonyl. Hexa means 6 CO group, which makes it octahedral in shape. And when we draw the octahedral shape, it will be chromium at the center and we have 6 CO group attached to chromium in octahedral geometry. So this is the shape of hexacarbonyl chromium 0. Now the next compound is number 4. It is decacarbonyl dimanganese 0. Decacarbonyl dimanganese 0. Now the structure or the structure of this compound is, this is the IUPAC name. So the structure is, it is dimanganese and decacarbonyl. Decacarbonyl means there are 10 CO group. So the formula of this compound is Mn2CO 10 times. This is the formula of the compound, decacarbonyl dimanganese 0. Now about the shape of this compound is, this compound is made up of 2 square pyramidal MnCO 5 times units joined by manganese single bond. So the shape is square pyramidal, means there are 2 square pyramidal MnCO 5 times units, and they are joined by manganese single bond. So when you draw the shape of this compound, it will be like this, Mn single bond, and you can see 5 CO group around each manganese. So 1, 2, 3, 4, 5 CO. Now around this manganese also we have 5 CO group, 1, 2, 3, 4 and 5. So there is an Mn bond and 5 CO group around each manganese. Now the last compound, metal carbonyl, that you have to learn is number 5. The name of the compound is octacarbonyl dicobalt 0. Now octacarbonyl means 8 CO group, and dicobalt again we have 2 CO group, cobalt. Now let's see the formula of this compound. The formula is dicobalt, which means CO2. This O is small and C capital because it is cobalt. Now it is octacarbonyl. Octacarbonyl means CO 8 times. So this is the compound, CO2, CO, and this carbonyl, carbon and oxygen are both big alphabets. The cobalt, carbon is big and oxygen is small. So this is the formula of the compound. Now the structure of the compound is, it has a cobalt-cobalt bond bridged by 2 carbonyl group. So when we are asked to draw the shape is, there is a cobalt-cobalt bond bridged by 2 carbonyl groups. So the shape will be like this. This is cobalt-cobalt bond bridged by 2 carbonyl groups, CO, CO. Now, so 2 carbonyl groups are bridged to cobalt-cobalt single bond. Now the other carbonyl groups are arranged in this form, that is CO, CO, CO. Here we have carbonyl groups CO, CO and CO. Now you can see total 8 carbonyl groups. So this is the shape of octacarbonyl dicobalt 2, in which the cobalt-cobalt bond is bridged by 2 carbonyl group. So these are the 5 carbonyl compounds that you have to study with their shape. Now next, let us see the bonding in metal carbonyls. Bonding in metal carbonyls. Now, you can see that bonding in metal carbonyl. So the bond will be formed between the d orbitals present on metal atom and between the carbon of CO group. Okay, so when you are asked to draw the bonding, if you are asked to show the bonding in metal carbonyls, we can show it like this. We have metal and the orbitals of metal. Which are the orbitals present in metals? The d orbital, and you know there are 5 d orbitals present in metal. Now we have here C triple bond O. This is our carbonyl group with oxygen carrying orbitals, And also we have orbitals on carbon atom. Orbitals around carbon atom. Now, let us see how a bond is formed between the metal and the carbon. Now, it is said that the metal carbon bond in metal carbonyl possesses both sigma and pi character. And you know, sigma bond is formed by s orbitals and pi bond is formed by p orbitals. So, we can say that the metal carbon bond in metal carbonyl possesses both s and p character, or there is a sigma and pi bond character. Now, how is this sigma bond and pi bond formed between metal and carbon? The metal carbon sigma bond is formed by the donation of lone pair of electrons on the carbonyl carbon into the vacant orbital of the metal. So, how is a MC sigma bond formed? Metal carbon sigma bond. MC sigma bond, how is it formed? It is formed by the donation of lone pair of electrons, and here on this, in this orbital of carbon, you can see the lone pair of electron, and this is donated to the vacant d orbital of the metal, and this results in the formation of a sigma bond. So, MC sigma bond is formed by the donation of lone pair of electrons on the carbonyl carbon into vacant d orbital of the metal. Now, how is an MC pi bond formed? MC pi bond. Now, MC pi bond is formed by the donation of pair of electrons from a filled d orbital of metal into vacant anti-bonding pi star orbital of carbonyl group. So, the pi bond is formed by the donation of electron from filled d orbital of the metal. So, here this d orbital, filled d orbital of the metal to the vacant anti-bonding, this is the pi bond, this is the vacant anti-bonding pi star orbital of carbon atom. So, the pi bond is formed by the donation of filled d electrons to the pi star anti-bonding orbital, okay, of carbonyl group. And we can see that here there is a back bonding, means there is donation of electron from the orbital of carbon to the d orbital of metal and forms a sigma bond. At the same time, there is donation of electron from d orbital of metal to the vacant pi star or anti-bonding orbital of carbon. This is called back bonding. And here you can see that this metal to ligand bonding causes a synergic effect. Synergic effect. And the synergic effect will strengthen the bond between the carbonyl group and the metal. Okay, so this is called synergic bonding or synergic effect. And how does it help the metal carbonyls? The synergic bonding will strengthen the bond between CO group and the metal. Okay, that is the effect of sigma bond formation will strengthen the pi bond and vice versa. As a result, the bond between CO and metal will be strengthened. So, this is our bonding in metal carbonyls. Okay. Now, next comes the application of coordination compounds. So, the next topic is application. Application of coordination compounds. The first application is it's used as a catalyst in many industrial processes. For example, we have a rhodium complex which is used as a catalyst and it is called Wilkinson Catalyst. Wilkinson Catalyst. This is a rhodium complex and the formula is PH3P thrice RHCl. This is the rhodium. RH is rhodium. Rhodium complex. It's known as Wilkinsons Catalyst. And it's used for, this Wilkinsons Catalyst is used for the hydrogenation of alkene. Hydrogenation of alkene. What do you mean by hydrogenation of alkene? Addition of hydrogen to double bond. Alkene is double bonded carbon. Now, the IUPAC name of this compound, this catalyst, PH3P thrice RHCl. IUPAC name is, the ligand is chlorido and PH3P. PH is phosphine and P is, PH3 is phenyl group, triphenyl group, and capital P is phosphine, phosphorus. So, let's write the name of the compound. The name of the compound is chlorido tris is 3 times, tris in bracket, triphenyl phosphine, rhodium, and the oxidation number of rhodium in this complex is 1. So, this is the IUPAC name of Wilkinsons catalyst. So, this is the first application of coordination compound. It's used as a catalyst. Now, the second application is, we know that the articles or things can be electroplated with silver and gold much more smoothly from solutions of the complexes of silver and gold. So, if we use the complex of silver and gold for electroplating the articles, it can be done more smoothly. So, that is the second application. And the complexes of silver and gold used is AgCN twice minus, and gold is AuCN twice minus. So, if you use these complexes for electroplating, then the electroplating will become more smooth and easy. Now, the third application is in black and white photography. So, the second application is in electroplating, third is in black and white photography. Now, let us see what is the application of coordination compound in black and white photography. In black and white photography, the developed film is fixed by washing with hyposolution. Hyposolution is sodium thiosulfate, which dissolves the undecomposed silver bromide to form a complex. So, in black and white photography, the developed film, that is fixed by washing with hyposolution. Hyposolution is sodium thiosulfate, that is Na2S2O3, sodium thiosulfate, and the sodium thiosulfate will form a complex with silver bromide, and the formula of the complex formed is, AgS2O3 twice 3 minus, or you can write this as, it is sodium thiosulfate. So, the 3 minus will be neutralized by sodium metal, or you can write the formula as Na3AgS2O3 twice. So, this is the formula of the complex formed when hyposolution is added with silver bromide. Okay. So, AgS2O3 twice. Now, this is the third application. Now, the last application is in medicine. Let us see what is the application of coordination compound in medicine. Medicine. Now, there is the treatment of problems caused by the presence of metals in toxic proportion in plants or animal system that can be treated by using chelate therapy. So chelate therapy is used in the treatment of problems caused by the presence of metals in toxic proportion in plant or animal system. Now, for example, excess of copper and iron are removed by the chelating ligands, and the name of the ligand is excess of copper and iron are removed by the chelating ligands, and they are D-penicillamine and desferrioxim B through the formation of a coordination compound. Now, next EDTA. We have heard about EDTA. EDTA is ethylene diamine tetraacetic acid. EDTA is used in the treatment of lead poisoning. This is also a coordination compound, EDTA. Now, next is cisplatin, another coordination compound, cisplatin. It's used in the treatment of tumors. And cisplatin formula is cis PT-NH3 twice Cl2. This is cisplatin. PT-NH3 twice Cl2. So this is the use of coordination compounds in medicine. So these are the various applications of coordination compounds. So with this we complete the metal carbonyl, the bonding in metal carbonyls and application of coordination compounds. Thank you.